let's give you guys some practice. So we've seen this before in the past. If you can, try to memorize this. When you differentiate tan, you will get this. And then if you try to integrate this, you will get tan. And remember that sec squared is given by this, so you can always imagine tan squared as sec theta take away 1. You can always imagine this as tan squared. Well, the question here is integrate this. Okay, so as a clue, just remember that when you differentiate this, you will get this, which will mean that if you try and integrate this, you will get tan. And then just remember that you can always break up tan squared as this take away 1. Okay, well that's a clue there. Do whatever you want. Integrate this. Okay, so press pause and have a go. Okay, so to do this, imagine to the power 4 as squared times squared. So earlier we said that tan squared is this thing here. So you can imagine it as this block multiplying with this block here. So now now multiply. This times this will give you this, and then this times this will give you this. And then at this point here, the question that should be going through your mind is, how is it that you know you should do? How is it that you know that you need to take this route? Well, you don't. It's really trial and error. So you have to really struggle with lots and lots of examples, and then over time you will get an idea of what to do. But at the moment, it is a lot of trial and error, because if you try and do this, there are so many ways there are so many ways that you can do this. But how is it that you know you should take one particular route? For example, you can break this up as this and this. So we could imagine this as sec squared of x minus 1 times sec squared of x minus 1. Well, we could imagine this as this, or we could imagine it as this. How is it that we know that we should take this route as opposed to this route? Well, it's through trial and error. After a while, you build up your experience, and then you get a gut instinct on what to do. But at the moment, if you take this route here, where you imagine this as tan squared, then for some reason it works out, and it's through experience. So for the time being, just take my word for it. So this times this will give you this. This times this will give you this. And then now break it up into two. So now imagine. So break it up into two integrals. Okay. So that will then. So you can integrate this as being one block, and then you can then integrate this as being another block. But then we are substituting this tan squared as this. Okay, so well, from here it is possible to get to here, and then now you can. So here you've got one thing minusing another thing, so you can integrate this and then integrate this. So you can do two separate integrals. Okay, so that will then take you to here. And don't forget, this bit might be confusing, because why is this a positive? Well, if you imagine this as being like one block here, at the moment you've got minus this whole block here. Well, this minus here, you can push it into here, because there's a minus 1 here in a way. So now this is a plus. So now the minus 1 times that, so you have minus sec squared of x, and then the minus 1 on this, that will give you plus 1, but then you can take the integral now. Okay, and then don't forget, this is like a plus all out here, and then now you can take the minus out, so that will give you minus minus the integral of sec squared of x, and then here's a plus, so it's a plus. Well, now you can see it's a minus here and a plus here. Okay, well, this might confuse a lot of people, because at the moment you've got a negative and a negative. Well, it's quite straightforward, but some people will get confused by this. So from here, you've got a minus here and a positive here. So overall, this will take you to this, and this is easy to integrate. By the way, when you integrate this, you're gonna get a constant here, plus c. When you integrate this, you're going to get another constant, plus c. When you integrate this, we can merge all these c's together to give us just one c. Okay, just bear that in mind. So, hang on. So now if you look at this here, earlier we said that if you differentiate tan, it will give you sec squared of x. Well, if you try to integrate this, then you're going to get tan of x. So this thing here, when you integrate this, it is tan of x. So we just bear that in mind. We know that this is tan of x. When you integrate this, it will give you tan of x. And when you integrate this, it will give you x plus c. And then now let's just concentrate on integrating this. Well, if you look at this here, remember when you come to integrate, try to look for something that's a derivative, where the derivative is inside the integrand. So for example, if you look at this here is your big clue here. This is a big clue here, because when you differentiate tan, it will give you sec squared. But then sec squared is within the integrand. So oops, sorry, hang on. I need a dx here. Bear with me. So I need a dx here. Hang on. I need a dx here. So sorry. So whenever you try and integrate something, try to look for a derivative being within the integrand. So if you make tan here, if you differentiate tan, you're going to get this, and then this is within the integrand here. When you're at this stage here, let u equals tan of x. Let u equals tan of x. Then du equals this thing here. Now you can see that the derivative here is, well, rearrange this so dx equals this thing here. Now put this, follow our normal routine, put this into the dx, put the u here into here, and then later on this here will get cancelled out with this. Okay, well let's just concentrate on integrating this. We can do this and we can do this. On a side note, let's just concentrate on integrating this. Okay, so hang on, let me go back one step, sorry. So we are trying to integrate this here. We are trying to integrate the whole thing. We know how to do this, we know how to do this. Let's just concentrate on this. Put this into the dx, and then put the u into here. That will then give you this. That will then give you this. And remember, we are only trying to work out this at the moment. We know how to do this, we know how to do this. Let's just concentrate on integrating this. So substitute back into here, substitute this into here. That will then take you to here. Now these two will cancel out, giving you this. Now this here is easy to integrate. That will then give you this. And then remember, we said let u equals tan of x. So overall this, when you try and integrate this, oops, sorry, I forgot a dx here. So when you try and integrate this here, it will give you this. So earlier we were at this stage here. We know how to integrate this. We know how to integrate this. Now we've just done this. This here is this. Again, forgotten the dx here. So overall the answer will be this. Okay, because we've just worked out this one here. We know that this is tan, and we know that this is x, and then we're going to merge all the constants together. Remember, when you integrate this, you're going to get a constant, blah blah blah, plus a constant. Integrate this, you're going to get blah 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 plus a constant. This one here, you're going to get x plus a constant. Merge all these constants together. That will then give you this. Well, overall the answer will be this. Okay.